Hello, everybody. Welcome to day 4 of both the web development bootcamp and the JavaScript bootcamp. I'm so excited. This is our first guest session we're having today, and it is my sincere honor to introduce both Barb and Zach. I'd love to give you an opportunity to say hello.
Hello, we're so glad to be here. It's very exciting for both Zach and I. Zach, over to you.
Very happy to be here. Thank you all for tuning in.
Wonderful. I'm going to use the chance, if I may, to gush just a little bit about the two of you before we kick off with our guest session. Barb here is a distinguished professor of engineering at Oakley University and helps run the Learning How to Learn course on Coursera, which is one of the largest MOOCs. No, it is the largest MOOC around the world. And Zach is a senior software engineer at Curology Incorporated. Zach is coming to us live from Denver, Colorado. And again, thank you so much for both of you for being here today. What we're going to be doing today, folks, is I'm going to be leaving you all shortly to let Barb and Zach tell us all about learning how to learn as programmers. I will be back later on after their wonderful presentation to help field questions and get a conversation going. So I will leave you all shortly. Remember, folks, give us your questions and I will read them out at the end. I'll be monitoring the chat. So I'm going to be around in the shadows. Jess is here too. It's going to be wonderful. So without further ado, I will say thank you to you both again, and over to you, Barb and Zach.
Hello, everybody. As Ramon mentioned, my name's Zach. I'm a senior software engineer now. I focus mostly on startups. I do technology consulting. I've built lots of production grade software systems, but if you were to meet me earlier in my life, there would be really no indication that I would be doing this. That there was really no sense that I would become a programmer. There was no great flair of technical ability. I wasn't doing algorithm problems at age 5. When I was a kid, I liked books. I liked playing classical guitar. I didn't start programming at a young age. I'm from a rural area in Maryland where there's not too much of a wide variety of professions. And I don't think I met a single person who built with code until I was well into my 20s. I didn't study computer science in university, and the world of code really felt like it was a mystery to me. It felt like it was something for an elite, right? It's this exclusive world where if you studied CS at Stanford, you can code. If you didn't, well, good luck to you, right? Whereas I was someone who had actually left school in 9th grade. So I had this perception of mine that coding was off limits to me well into my career. And I was almost entirely focused on people, soft skills, business, stuff like that, not technology. That's what That's what I was good at. And that's what I believed would define my career, and that it would sort of be impossible for me to change my brain and become technical. That I was very wrong.
I'll say, and actually, my story is somewhat similar to Zach's. I was a little kid who, I was terrible at math and science. I flunked my way through elementary, middle, and high school math and science. I loved animals. I loved knitting and weaving. I thought I could never do anything technical. So I kind of looked towards what I could do as my career, and I decided the best thing was to maybe try to learn a new language. And I know for many of you who speak multiple languages, it seems almost trivial, but for me, it was quite an exciting idea. So I couldn't afford to go to college, but I found out there was one way to learn a language and actually get paid for it, and that was to join the Army. So here you see me looking really nervous, about to throw a grenade. And if you knew how clumsy I actually am, you would know why I look so nervous. But I did learn another language. I learned Russian, ended up working out on Soviet trawlers up in the Bering Sea. And I just loved having new adventures and seeing the world through different perspectives. So I also ended up at the South Pole Station in Antarctica, and that's where I met my husband. So I always like to say I had to go to the end of the earth to meet that man. But but then I began to realize that here I was, 26 years old. I was going to get out of the military, and there were no recruiters knocking on my door trying to get hold of my Slavic languages and literature abilities. In fact, by following my passion and learning a language and not doing anything else, I put myself in this sort of career box. And I realized that it was important for me to try to broaden my skill set if I wanted to have a job that I would find interesting. So I thought, well, I'm supposed to be open to new adventures and new perspectives. Why don't I see if I can have a new perspective of the mind and change my brain to be able to learn in math and science? And to my shock, I was able to do that. And it wasn't like this overnight switch or anything. But now I am a distinguished professor of engineering, and it happened bit by bit. And I gradually became better and better at what I was learning because, as you will see, just learning a little bit makes the next bit a little bit easier. So I think back to you, Zach.
So to kind of understand the neuroscience of moving from beginner to expert as a programmer, we have to start and agree on a couple things. The first is that programming is really weird. It's an extremely weird and unnatural behavior, right? If you think about what programming is, it doesn't fit into humans' evolutionary past very well. Thinking about abstract symbols all day for 99.9% of human history was a great way to get selected right out of the gene pool. So it's not natural to sit in a chair and try to find out where you put the semicolon. And programming also demands an unnatural level of intense focus. The kind of focus that programming requires was typically only applied in bursts, adrenaline fueled bursts in the past because you were hunting, or you were running from a predator or fighting or some other intense thing, right? Whereas programming is demanding this on a daily basis. Even by modern standards, programming is strange, okay? So engineering in the 19th and most of the 20th century, it was much more physical, it was much more hands-on. And the constraints that you were encountering while building were hard. They were the laws of physics, right? But software systems don't really have those same kinds of constraints. They're highly malleable. In other words, they're easy to change. Oftentimes, the constraints that you face as a software engineer are imagination, how hard is it to maintain some code, and just simple, boring human factors like how many engineers are on the team so that can we realistically build this thing, In fact, some people argue that software systems are inherently more complex than physical systems because they're designed, you can't visualize the design in detail and understand all of its implications and all in the same way that you can blueprint a car, for example, or blueprint a house. This makes software so powerful and so wonderful, but also so confusing. The unlimited freedom that you have as a builder with code can be completely overwhelming. So to thrive in such a strange, by historical standards, and unique and young discipline, we should assume that many of our default behaviors, many of the things that we do that we're most comfortable with when learning may not actually work that well. And perhaps some possibly eccentric behaviors and habits can help us in a new field. The other thing that we need to agree upon is that programming is hard. The image here that you can see in the background is actually a chart from a popular blog post that's called How to Learn Front-End Web Development. In theory, I think this chart is supposed to make people feel comfortable navigating learning path. I don't know about you, but and I work with a lot of these technologies. This chart is so.
Oh, is everyone else hearing a little bit of static on the line there? Jess,
Sorry.
Ramon, I'm hearing a bit of static.
Hey, yeah, sorry to cut in. I am hearing it's like
Uh,
cutting out a little bit, I think.
See if I fix it.
Don't know, Zach, if you might have to either maybe it's a connection issue or maybe uh your computer's got a couple too many apps open or something.
Just-
It's pretty glitchy there.
Yeah. This let's see. Maybe Zach, it might help if you switch browsers. That usually does it for me. But in the meantime, if I may, already while Zach gets that fixed, I'd love to say how incredible and inspiring both your stories are. This has been wonderful to listen to so far, and it's so inspiring to see that such different backgrounds can give us um, so much enablement in our learning. Um,
I think something that's important for people to realize is that, it's not like some kind of thing where suddenly magically you become comfortable in learning something new. Instead, what I've done, and I believe Zach has done the same, is that we've become more comfortable with feeling uncomfortable.
yes.
So, in other words, you're totally, weirded out, and you're second guessing yourself, and you're saying, "Oh, I can't do this," and to realize that that's okay, that's perfectly normal. Practically everybody has that, and if you don't have that, it actually can be a problem. For example, in my engineering classroom, the students who come in all cocky and they think I got this, they're often the ones that really don't have it, and they can flunk out and so forth. They're overly cocky about what they know and can do. Whereas if you approach it with this perspective of, gee, I'm not sure I could do this, it's a big change, I'm coming at this from something utterly different, this actually can be helpful for you, because that little bit of nervousness, or a lot of nervousness, helps you to try harder.
I agree wholeheartedly, and this is something that I bring into, I think, my everyday work, and something that when I'm talking to folks who are, when I'm talking to folks who are relatively new to programming, and I notice that I think something that's quite common is that some folks feel like that have been around for longer, those that have been, those that are senior software engineers, that we think seem to know everything, and that we never get stuck. And in fact, one of my favorite things about doing so many things live, as opposed to making properly produced videos, is that I find that sort of helps us. That helps me eliminate that possibility. I will make mistakes. Heck, I made mistakes yesterday while teaching. I used the wrong variable names, and it was fine. As you said, being comfortable with being uncomfortable is something that I think is critical for being able to thrive in I would say most of our daily applications. So I see Zach is
Except
back. Sorry.
you, Zach.
Hello.
Oh, you
Oh, that
sound
sounds
great.
great.
Okay. Sorry, everybody. I apologize.
Not at all. Not at all. I'm very glad everything's working again. I will see myself out. See you all in a minute. Best of luck.
Great. So we were talking about how programming is hard. This chart, it's hard. It looks crazy. It's supposed to be reassuring, but I don't find it reassuring at all, because it just throws this brutal sense of how many technologies and how much complexity there is to just become, say, a front end software engineer. Each node in this big chart represents another tool or a piece of the web developer's toolkit. And if you think about it, each one of these nodes is also changing all the time, because the pace of change in technology is so fast. Every week it feels like there's a framework that is the hot new thing and that you're expected to learn. And really, you are paid to learn every day as a developer, because this graph is constantly moving around, and you always need to be updating your skills and your knowledge. So let's understand then where we're starting here. Software is unnatural and it's hard, and it demands constant learning in complex and fast moving environments. So learning how to learn is just as relevant and maybe even more relevant for software engineers than in many other fields that don't move as quickly. To understand how to navigate this space, we need to understand how the brain actually learns.
So, understanding how it learns is actually more simple than you might think. How your brain learns is simpler than you think. And of course, we do know that the brain is a really pretty complicated sort of gizmo, as you might think of it. But in reality, it kind of, for our purposes, um, centers on one specific building block, and that is the neuron. And the neuron is, it's really pretty simple if you just think about the main ideas. It's like it's got these legs at the bottom, which are called dendrites. So legs, toes on the legs, those are called dendritic spines. And then an arm that reaches upwards, that's called an axon. And what happens when you're learning is you are actually making connections between neurons. So you've got a little electrical signal that jumps along these neurons. Of course, it's jumping across these synapses through neurotransmitters, but that's not really so important here. It's just the basic idea of when you learn something, you're creating sets of links between some neurons in long-term memory. And that's whether you are learning a certain algorithm, or you're learning a dance move, or how to take a derivative in math, or conjugate a verb. Whatever you're learning, if you've learned it, you have actually made connections between neurons in long-term memory. So as you practice more, you are, no surprise, strengthening those connections. And ultimately, as you learn something, you are creating this nice set of links, almost like this nice little necklace that you can pull to conscious memory, conscious working memory, and use it when you want. So if you don't have those sets of links in long-term memory, you actually do not know the material. So the bottom line is then that these sets of links are really important. And if people tell you you don't need to memorize anything, you can always just look it up, just know that that is really quite untrue. You need to have, could I speak French if I just use Google Translate? You need to have foundational information in the brain if you really want to be able to work with it. So the brain has, in essence, it's those sets of links are in the neocortex, which is a very thin layer on the surface of your brain. So if you watch very closely, you'll see this thin little layer. And come here, oh, there we go. Okay, so there's this thin layer. It just expanded. So this is, we've got it on each side of our brain. We've got this thin layer, and it ultimately, when you fold both sides together and you fold them out, they're about the size of a dinner napkin, and they're about that thick, 2.5 millimeters thick. And that's where the great bulk of all your learned information is stored. So this kind of leads us to, I think, a very important idea that is just that your brain is not a bunch of mush. It's actually part of your toolkit.
That's right. So when you think about what people usually discuss when they're talking about how do I learn to become a developer, how do I get better as a developer, there's an amazing amount of stuff written about tools and philosophies of software development, and how do you do project management in software, and books and courses, and more monitors, and how do you write clean code, and there's 1,001 tools and approaches. But much of this education is about technology itself, clean code, testing, scalable architecture. Companies will train us in how we use the specific tools of our work, GitHub or Amazon Web Services, or all these things that you'll encounter here as you go through your career. And companies are great at helping people learn that stuff. But too often, missing at the very center of everything, as Barb just pointed out, is the human with the brain, that the brain is this piece of the tool chain. And there are more and less effective ways of using that piece of your tool chain. Generally speaking, developers are not trained explicitly in workflows for how to execute stuff with our brains, right? But between the problem and you is between the problem and the code that you write is you, the human, right? For example, has anyone candidly talked to you about focus, time management? How long do you spend on a bug before you take a break? Procrastination? How do you systematically learn a new technology? Anxiety management, the effect of smartphones and social media on programmer productivity. All of these things are just as much part of your tool chain and can just massively improve your ability to function as a developer and to learn software development. But they're often not focused on. So that's really what we're focusing on today. I'd also like to point out that these are not the same thing really as soft skills. You'll hear a lot of talk about soft skills in development. Soft skills are important, being able to communicate clearly, keep something in a business context, write a good piece of documentation. These are all really valuable skills. I'm not knocking soft skills, but they're not quite the same. This is about the effective use of your brain and how the sort of cognitive tool that you have at the center of all this work. Now, the effective use of your brain matters because your brain, everyone's brain, has serious limitations.
And so this brings us to sort of how does the brain really learn? I mean, if we really want to understand those serious limitations, then we need to understand how the brain is making those limitations. And the first important thing to understand in that regard relates to long-term memory versus what is often called working memory. So long-term memory is where we've got those sets of links stored in the neocortex. Working memory is in our prefrontal cortex in those kind of the front of our brain. And I like to model this with an octopus. So, and the reason for this is, well, an octopus normally has 8 arms, but we've come to discover that working memory really, it can hold about 4 things. So I use a quadrupus, which has 4 arms, and those 4 arms represent the 4 pieces of information that your working memory can reach up and grab. So if you look here, let's see if I can, there we go. So you can see how working memory reaches up, grabs a set of links from long-term memory, and then it's able to work with those sets of links. So as you're learning, as you're in this boot camp and moving along, your working memory is working to learn the material and create sets of links that are being stored in long-term memory. And then whenever you need those sets of links, your working memory can go, oh yeah, that's the algorithm, that's the whatever this little topic or big topic is, and it can pull that idea or technique from your working memory. So this brings me to our younger daughter, Rachel. And Rachel she at the time had recently learned to back up a car. So I asked her if she would model for us what it first felt like when she was learning to back up a car. And look at how Rachel is trying to learn this new and difficult skill. She's trying, she's looking to the front, she's looking in side mirrors, she's looking towards the back. She really doesn't quite know how to back up the car, and she ends up in the ditch. So it's hard learning to back up a car in a very similar way, it's hard to learn some of these new ideas in programming. What's happening is your working memory has what's called a heavy cognitive load. So see all those arms of the octopus, they're really busy. And so they just don't have any extra space available or extra arms available to grab onto any other ideas because you're totally preoccupied with this thing you're trying to learn. Yeah, so you might think of it like this. Let's say you're sitting beside someone who's learning to back up a car. You would not probably initiate a conversation about a random subject as they were trying to back up the car because they just don't have extra cognitive abilities, available, no extra arms to also be paying attention to you. But once that person has learned to back up the car, it's super easy. They can, they've got a very light cognitive load. All they have to do is think of the idea. I want to back up a car. They pull that skill set or set of links into mind. Light cognitive load. That means they've even got other arms available in their working memory octopus in order to be able to think about things like, what's on the radio, is my seatbelt fastened, or all of these kinds of things. So ultimately, when you learn something really well, let's say that you're sitting at your job and you've got to come up with some kind of new way of working out this problem you've been dealt with. So as you may be sitting there and you look at the problem, it has many different concepts that you have learned well. So you're able to link them together in new ways to create, for example, a new algorithm that you need in order to accomplish some specific task. So the thing is, let's say you don't have those links in working memory because you haven't practiced with those underlying ideas, what can happen is you sit down, you're trying to work, and you're overwhelmed. You're not able to really put together these new ideas because you don't have a good solid set of sublinks to link together easily in your mind. So people have different working memory capacities. On average, people can hold about 4 things in their working memories. Some people only have 3. Other people have many arms on their attention octopus. They can hold a lot of information, and this helps them to learn faster. So you might think that having a great big working memory is the be-all and end-all. Well, guess what? That's not true. I myself have a limited working memory. So I'm more like this 3. And it turns out that people with lesser capacity working memories are often A, more creative, and B, they're more flexible in their learning. In other words, if they learn something and it's wrong, they can actually go back and say, oh, wait a minute, I did this wrong. Whereas the really fast learner can find it much more difficult to go back and rethink what they've done and find errors. So each type of working memory has advantages and disadvantages. Now, ultimately, I like to think of it as the people with large working memory capacities are like race cars, and people with lesser capacity working memory are kind of like hikers. But also remember, race car, everything goes by in a blur. Hiker, they're walking through, they can reach out and touch the leaves from the trees, smell the pine in the air, hear the birds, completely different experience, and in some ways, much richer and deeper. In fact, some Nobel Prize winners are hiker type learners, and they won the prize because they looked at all the little details The race cars just jumped right over and took for granted. But the hikers were able to see where the problem was. And even though it was harder and slower for them to learn, they were able to solve problems that the race cars could not. So ultimately, especially if you are a hiker type learner, scaffolding is really helpful for you. And by scaffolding, I mean you'll get a big chunk of material to be learned. And a race car can handle bigger chunks. A hiker like me, they can still learn it quite nicely, but by breaking it up into smaller components. So small chunks with plenty of practice is really helpful for hiker type learners.
What the working say programmers day to day?
Uh-oh, I think we've got some problems on the static again.
Yeah. Apologize.
No, still static here.
How about now?
Perfect.
Okay, we're gonna apologies, and we'll just go for it this way. So what does all this talk about working memory have to do with the programmer's day to day and the programmer's workflow? So as Barb mentioned, there are variations in people's working memories. And so you will often hear something along the lines of, well, programming has this talent dimension, and talent usually is kind of standing in for working memory in those conversations, because a person might have that they just can take in all these variables from the program and have it all in their head at the same time. And, you know, eureka, they have this great insight and they're just typing 1,000 words a minute. And that's the sort of race car archetype, right? But regardless of where you stand on this spectrum of working memory, there are habits that all of us have, you know, the overwhelming majority of people have, that work against how you use the working memory that you do have. So we have the opportunity here to use our working memory better, regardless of where you are on that spectrum. So let's look at a few examples. The first might be, you know, when I'm trying to find that one tab with the docs that I'm looking for, right? How many people's browsers look like this? Like I'm totally guilty of that. And I can share some techniques for dealing with this, because I think it's a harder problem than it seems. Or maybe when I'm trying to find that one error message or that one console.log that I was looking for, right, in the console. Or maybe I'm trying to find that one file that I was working on in my project, right? You know, you sit down and you're going to program and you have 1,000 windows open, 1,000 files open. There's notifications popping up everywhere. There's a cell phone chiming next to you every 10 seconds. I find that when I pair program with early career developers, that oftentimes this is what I see in their workspace. And, you know, 50 tabs and windows and console spam, and they're logging like 100 things with subtly different messages, you know, all throughout the code base, all of this. And when I ask them, hey, like, what's the problem that you're actually working on? They'll meander through the files and kind of get lost along the way. And they'll say something like, well, I was going to fix this button on the login screen, but then I realized the user module needed a refactor. But then there was this one bug in the unit test. And then, like, what were we talking about again? This kind of saturation of your working memory, it leads to dumb mistakes. Like I've paired with people, for example, and I have myself made this mistake where the problem is I forgot to save a file with my changes. And then I was looking and being like, why isn't my change there? What's happening? Why is this broken? I don't understand. You know, in a similar vein, I will often also see on the screen printed an exact explanation of what an error is, what the error is. Like the computer will literally be telling the programmer, this is what's wrong. It'll be right on the screen, but people have become so saturated with so much noise that they can't see even just what's right in front of them. And so what matters is lost in this sea of noise. My point here is that being deliberate about controlling your cognitive load and using your working memory well will make it easier for you to program and to solve problems. So the next time that you're stuck on something, you're stuck on a bug, or you're needing to figure something out, what I like to do is close all the tabs, all the windows, everything. Do not disturb everything. We'll talk about techniques in a minute, but get rid of all the noise so that I can see where the signal is and I don't get lost in the digital jungle. Now, indeed, this idea of working memory reaches to the heart of software design itself. As you get more experience as an engineer, you start to hear these principles of good programming. And while most people don't describe it this way, many, many, many of the principles that you hear are actually about working memory management. So when you hear someone say, "Oh, well, this is a good programming pattern," or this is an example of a well-designed system, oftentimes I substitute in my head, "Oh, this system manages working memory well for the human." Good programming is about abstraction. Abstraction is about hiding complexity, and hiding complexity is about freeing your working memory to focus on one thing at a time. Now, Stanford University professor of computer science, John Ousterhout, has this wonderful quote here, which is that the greatest limitation in writing software is our ability to understand the systems that we're creating. Complexity accumulates. It becomes harder and harder for programmers to keep all the relevant factors in their mind as they modify the system. So all of the things that you hear, avoid complex state, avoid huge functions that do too many things, avoid shadowing variables. You'll hear all of these things, I'm sure, even in the course of your boot camp. These are things that are meant to economize the memory of the programmer. And we want to do this so that we can free our minds to focus on the higher level building blocks of our system. Okay. Now let's talk about anxiety. A second skill, like working memory management, is anxiety management. Now, people usually laugh when I say anxiety management is a core engineering competency, but that's what I'm going to argue. It sounds weird, but let me explain. Anxiety is a part of the problem-solving experience. The nature of software engineering is that every single day you encounter problems and things that are broken. You live in a world where everything is broken all the time. That is the world of the software engineer. And every time you encounter something that's broken or something new that you have to ship, you feel some sense of unease. This has led a lot of people to point out that programming is as much about tenacious problem solving as it is about just being smart, right? Now, I agree that there's this important tenacity element of being successful in programming, but I'd like to think of programming more as it's about using the tenacity that you have intelligently. In other words, managing your anxiety as much as it is about being smart or just being blindly tenacious and never giving up. All right, so there are two ways that anxiety creates problems for software engineers. And the first of these is what I call code frenzy mode. So we're going to watch this gentleman go into code frenzy mode, which I'm sure all of you can relate with. In my first year of programming, I would work myself into a frenzy of frustration rather than recognizing, hey, my brain's overwhelmed. I need to take a break. I don't know how to solve this thing right now. You know, I felt like it was giving up, and I kind of associated a bit of shame with this. And I thought, like, if I only spend another 10 minutes focusing as hard as I possibly can, the answer would then just become obvious. And like, what's wrong with me? Just like, I'm 10 minutes away from solving this problem. This was delusional. And all it did was it made me mad and it made me stressed out. And honestly, it probably made it harder and it made it take longer to solve the problem than it needed to take. I was completely working against myself. Believe it or not, taking a break in an intelligent way, which Barb will speak to in a minute, taking a break is part of programmer productivity. Why? Because it is part of managing that anxiety that builds up like trapped steam the longer that you bash your head against a particular problem. Now, I'll pass it off to Barb here to talk about why taking a break is a scientifically valid part of problem solving.
So if we look at the brain and how it functions, it has two entirely different modes. I mean, if you're mathematically inclined, they're orthogonal from one another. The first mode is the focus mode. And it's probably, I hope, what you're doing right now. You're focusing on the screen and really turning your attention, which actually is a critical part of learning. So, and it turns on various neurotransmitters and neuromodulators that allow you to learn. But there's another mode, and that's where you're not focused on something. And that's called, I'll call it diffuse mode. Neuroscientists call it the default mode network, and psychologists call that the task negative network, as opposed to what they call the focus mode, which is the task positive network. So you've got these two different modes. One is when you're concentrating, and one is where your brain is kind of, I mean, it's still thinking, but it's not like focused on something external. So to understand these two different modes, we're going to use a metaphor. And metaphors are really powerful tools for learning. And the metaphor we're going to use is that of a pinball machine. Now, if you're my age, which you probably are not, you'll remember a pinball machine, but they're used now commonly in many video games. And all you do to play pinball is pull back on the plunger in real life. And what happens is a ball will come out and go bouncing around on these rubber bumpers, and that's how you get points. So this pinball idea can be applied to the human brain. So watch as we see the human brain with a pinball machine on it. So when you're thinking about something, let's say that I asked you to multiply 22 times 23. You've already got some patterns there because you have learned multiplication. And when I give you a specific problem, like 22 times 23, that sort of ball of learning, or that mental thought, travels along the neural pathways you've already laid because you've already learned how to multiply. But let's say that you are trying to learn something completely new, so you don't have pathways already. Let's say you're trying to learn division, for example. So you're trying to learn division, a new set of pathways, but what can happen is, well, those multiplication pathways are really comfortable, and you can find your thoughts slithering back into incorrect pathways, and that means you can't solve the problem. So how do we learn something new then? I mean, if we're always slithering around and going off track with things, when we do go off track with things, we get really frustrated. In fact, we can get more and more frustrated. And eventually we can close the book, or we turn off the video, and we might go have dinner, or go for a walk, or go take a shower, or even go to sleep. When we take that break, what happens is we are, for a little bit, temporarily in the diffuse mode, in that very different way of thinking. Look at how different it is. Here in focus mode, we have close connections. In the default mode network, or diffuse mode, those connections, it's a much broader range of connections. So when we're thinking in this mode, our thoughts range much more widely. We can't use this mode to solve the specific problem that we needed to solve necessarily, but we can use it to get to the new perspective we needed to be in order to be able to understand and solve that new problem. So what often happens with learning is you are going back and forth between these two modes. Focus mode, as you're trying to first grapple with an idea. Diffuse mode, as you're trying to maybe overcome some misunderstandings and frustrations. And also while your brain is consolidating and compacting what you've just been learning, then you come back again to focus mode. You go back and forth between these two modes as you're learning. And the interesting thing is that, well, you can't be in both modes really at the same time, unless you're taking certain forms of mushrooms, and I am not advocating that here. But ultimately then, this leads us to another topic altogether.
So this is everyone's favorite because we all suffer from it. The second way that anxiety and anxiety management is really important to software engineers is through procrastination. Procrastination can really, really hurt your career as a software engineer. You do not want to be the engineer that has the reputation for procrastinating your work. And in fact, overcoming procrastination regularly with your team and shipping stuff, I would argue is probably one of the most powerful ways to advance in the discipline, because you're known as that person who gets things done. Procrastination really can stand in the way. Now, I feel almost everyone tense up usually when I talk about procrastination because everybody suffers from it. We all feel embarrassed, and there's something about the topic that makes it feel like it's a personal failing. You know, it's a matter of your own failed character or something like that, as opposed to procrastination being part of this broader picture of anxiety management and the brain. So as we've seen in what Barb just shared, you can effectively manufacture problem solving by loading all the variables of the problem in your head. In other words, focusing and going into the focus mode and focusing on the hard part, and then relaxing, going into the diffuse mode. But the risk here, right, is that the only way that switching between the focused and diffuse mode works is if you actually do the focus part, right? The best programmers focus in and stick with the problem long enough to really get all those variables in your head. And they're truly, totally focused on the problem when it's time to be in that focus mode. Otherwise, you're not equipping your brain to deliver insight. You're not loading in all the relevant variables, and then the diffuse mode can't actually do the thing that that it needs to do. So, what stands in the way of programmers and their intelligent use of the focused and diffuse mode? Well, one of the first things is just the programmer's workbench, which we'll talk about here in a minute. When people turn their attention to a bug or a feature or a task that stresses them out, they'll instead follow a kind of happy path. And that happy path leads to the phone, or idly checking email, or going on social media, or basically anything other than the task at hand, because the task at hand is unpleasant and everything else seems pleasant by comparison. Now, the digital age that we're all working in has made distraction especially challenging for two reasons. The first is that big tech companies optimize their experiences to make sure that you get sucked in, and so that it captures your attention. We've all heard a lot about this, but it's a real thing that is working against you as someone who wants to be a digital professional or who is a digital professional now, right? I think lesser understood in this problem is the power of the social element that makes a text message or an email or a social media notification an especially potent distractor. If you see a notification for social media or an email or a text, it carries a social expectation, and that's respond, right? Remember the hunter-gatherers that we saw in the very first slide, hunting the saber-toothed tigers? Humans are social creatures. You did not evolve to just coldly ignore everyone around you, right? If you think about how hard it is to ignore someone, if you're, say, in a normal office at a desk, and someone comes and stands at your desk and looks at you, even while you're working, you can sit there and you can try so hard to stay focused on your work, but the mere presence, the mere expectation of that interaction is so powerful that it pulls you away from your work, and you can almost feel your brain start to spend energy on, oh, this person's standing here, oh, what is it that they're going to want, oh, how long is it going to be before I need to look at them, all of that. And of course, this is the reason that a lot of programmers don't like an open office plan, because it comes full of all these social expectations. So if we feel distracted in the desk example, why is it that so many software engineers and so many digital professionals, they basically import the most damaging parts of the open office plan into their workflow, because they make it so easy to become digitally distracted on their computer, in what they're doing. With notifications, for example, a social expectation, it becomes this bit that starts draining your brain. It's in the back there, and it creates a background process of anxiety, right? I need to answer this person. I need to respond to this email. What if something important happened? There's an emergency in the text message. In computing terms, we might say that each notification consumes a little bit of RAM. I think programmers have it especially hard in this world of digital distraction. Why? Well, because if you're like physically building something, or you're working on an assembly line or something like that, you can't really do it in a halfway distracted fashion. You know, like the guy in this photo, he can't really be like cruising Facebook at the same time as he's operating this huge machine, right? He can't use a lathe while tweeting at the same time. But the programmer, right? We live in the browser. You know, you're refreshing that website you're working on, and the same UI that we use to entertain and distract ourselves and connect with other people is the experience that we are expected to use to create value, to write code, to ship a product. And honestly, companies often don't help here, right? They want their programmers always to be available in Slack or for a quick Zoom check-in. And this also layers on more expectations that draw you away from the focus mode. Focus programming is really easy to fake, and programmers do it all the time. They fake it. We're all guilty of this. I'm also guilty of this. You know, you may have your files open on your computer, but Facebook open in another tab, or on another monitor, right? Or maybe my phone is on vibrate while I'm debugging. The mere presence of distractors like these is a bad idea. Now, to understand the power of digital distractors and its relationship with anxiety and procrastination, we need to look at how procrastination functions in the brain.
So, the first thing about procrastination to realize is that when you even just think about something you don't like or don't want to do, it activates a portion of the brain, the insular cortex, that experiences pain. So, what does that mean? It means that you get this unpleasant feeling, so you just turn your attention to something more pleasant, and the result is that you feel happier almost instantly. But it's only temporary. In fact, you can procrastinate enough that it can affect your job performance. It can even affect whether you can successfully complete a boot camp, because you actually can. But if you procrastinate too much or very much, it can mean that whenever you are buckling down to study, it can be so stressful to try to learn in these compressed periods of time that a few people can do that. And then you feel you can't do it when you actually could if you had more time. So I'm an engineer now. Let's just cut right to the chase. What's the best method for tackling procrastination? The Pomodoro technique. This was invented by an Italian, Francesco Cedillo, in the 1980s. It's so simple. That's why it has swept the world. And indeed, in the course Learning How to Learn, I think one of the tips and techniques people find most helpful, that I've heard from thousands of people about, is this Pomodoro technique. So what is it? To do a Pomodoro, as I call it, you just turn off all distractions. So no ringy-dingies on your cell phone, no pop-ups on your computer. Good luck if you have a 2-year-old at home, but just do your best. Set a timer for 25 minutes. Focus as intently as you can for those 25 minutes. If you find that, you've gone off and you're in some other window and you're on Facebook or something, just as soon as you catch yourself, bring yourself right back and continue to focus, because the reality is anyone can focus for 25 minutes. So, and just bring yourself back, as your monkey mind might take you accidentally off task. Then, when you are done, and this is the most important part perhaps, is to reward yourself with a 5-minute or so break. And what this is doing is you are using focus mode, and then during this relaxing break, you're using the diffuse mode. So it's a great way to alternate back and forth between these different ways of learning, because we often have felt that focusing is the only way we learn, but it's not true. We learn both when we're focusing and when we're taking that relaxing break. So, by relaxing break, I mean this: do not go check your emails or text messages to see if you got anything there. You might say, well, that's a relaxing break. I'm just taking a peek. But if anyone texted you or emailed you, you will start responding. And guess what? You're just returning to the focus mode. Neuroscientists now realize something very important, and that is that uh, when you are taking that break, that's when your brain is able to consolidate those new links, to kind of reinforce and connect those new links that you were just learning about. So what's really happening is your hippocampus, when no new information is coming in, the hippocampus is able to turn around and tell the neocortex, go ahead and practice with these particular links. But that hippocampus cannot do that if it's still getting new information. So truly, something relaxing, for example, going for a walk, preparing a cup of tea, maybe listening to a bit of music, but nothing where you're doing more focus during that little reward period. And you will find this is one of the most powerful techniques to help you advance your learning. So I think here's something that's probably really important.
So let's talk about concrete techniques to help you deal with distraction and procrastination. We'll talk about some behaviors and also some software approaches. The first is to hide your cell phone, which is really hard to do, and I totally recognize that. But the key is to not just have it on silent, but also not have it in nearby in eyesight, because even just having it in eyesight, your brain is like, oh, there it is, it's pulling you away from that focus mode, and it's so easy to pick up. Some people have gone to really extreme lengths to make this possible. So this is an image from an Amazon listing for containers, where you put things in the container, you set a timer, so let's say 25 minutes, and the timer locks, and you can't get anything out of the container while it is locked. I thought this was really funny because you see the examples that they use. It's basically junk food and your cell phone, which I thought was a very interesting relationship there that's communicated through this listing. Now, let's talk about some software approaches to dealing with this. You could take the approach of obviously putting your phone on Do Not Disturb. In fact, this kind of stuff has gotten so popular, and it's become so important that most newer phones actually have options where you can allow particular people to bypass Do Not Disturb. So, for example, if you're married, or maybe you're a caretaker and you need to make sure that some family member or some other person is able to contact you, you can allow them through Do Not Disturb, but it will block out everything else. I use Do Not Disturb every single day, and the only people that can contact me are my wife and PagerDuty, which is a program that we use to monitor our production systems where I work, where if something goes down, I need to know about it right away. I have done this for years, and really it helps so much. Now let's talk about some of these other software solutions. Freedom is a software suite that runs in the browser or runs on your desktop that blocks certain applications by time of day. So you could block Steam and video games, right? You could block Facebook, you could block Twitter, whatever it is that you're having a problem with. Freedom is a beautifully designed and really functional product that works really well. Again, I use it every day to help me. Rescue Time is similar to Freedom, but what it does is it monitors what you do. So that sounds a bit creepy. It's not like sending it off to advertisers or something, but what it does is it sends you every week raw data on your productivity. And I can tell you that the output of Rescue Time can be really sobering. The first few times that I used it, I thought, oh my God, I spent that many hours. Like, on Twitter or in my email, what, I can't believe it. But having that sense of transparency and really seeing the data as it is, it helps educate you on where you might need to invest some effort, and it helped me recognize my bad behaviors and to get back on track. Then there are apps like Forest, which gamifies the process of doing a Pomodoro. I also don't have the logo here, but would like to promote an extension called Nuff Tabs, Nuff tabs. It allows you to set a maximum number of open tabs in your browser. I recently started using this, and I find that it works wonderfully, wonderfully well.
So, and I think that it's important to re-emphasize what Zach is saying, and that is that you can have these feelings of wanting to procrastinate, and they're very, very common. And learning to tackle them is really important. And you shouldn't feel bad about yourself if you tend to procrastinate. Now, the great thing about learning to handle procrastination in more effective ways is that it actually gives you more time. So, for example, yesterday I had a brand new presentation to prepare on a topic I have never spoken about before. I didn't know how I was going to put it together. It's painful for me to actually try to consider how to do these kinds of things. And I was like, oh, I don't want to do this. And I'm like, the first half of the day was spent in unhappy behavior. But I just set some Pomodoros and kept working away. And then it started to come together. And then by golly, at 4 o'clock, it was all done. And so instead of kind of putting it off all day and then starting later and just feeling bad about everything all day long, I got it all done at 4 o'clock. And in celebration, my husband and I went off and watched The Sopranos, which we are enjoying right now. So learning how to tackle procrastination well just takes a lot of pressure off, because you get the things done you don't want to do, and then it's out of your mind. But the reality is that learning, as we're discussing now, involves many, many different attributes. And so it's kind of like baking a cake. You've got lots of different ingredients to the cake. So I want to switch our attention, our focus for now, to a different aspect of learning. And perhaps this can be best exemplified by my favorite athlete of all time, Julius Yego. And Julius is from Kenya. And if you know anything about Kenya, you know they're famous for their long distance runners. But if you look at Julius's arms, it is quite clear he couldn't be a long distance runner. And in fact, he always wanted to learn to throw the javelin. But there were no javelin throwing coaches in all of Kenya, and he couldn't afford to go overseas and study. So he went to YouTube and he started looking at how, good instructors about how you can throw the javelin. And 99% of the time, simply by watching good instructors on video and then going off and practicing with the javelin, he became the world champion in throwing the javelin. So whenever people tell you, online learning, it really isn't as good as face-to-face. Au contraire, you can actually learn oftentimes even better online because you don't have those distractions, and also good educational videos or sessions like this one. We have carefully prepared and put together a talk or a presentation that actually gives you the best of what we can share to help you learn effectively. So online learning is a great way to learn, and boot camps online are fantastic. But I want to give you a little insight about what needs to happen to help your online learning be solid and progress well. So this relates to, just give you a tiny bit on the history of education. For thousands of years, people thought, well, the only way people learn is when someone lectures to them. So you might sit in front or sit in a classroom or in front of a professor or an instructor for hours and hours as they lectured you. Well, it has become clear in the last 50 years or so that this isn't necessarily the best way for people to actually learn. So then this new idea came about that, oh my gosh, active learning, where the student sits and actively works with the material, that's where it all happens. And so everything went crazy with, we got to always have active learning. Well, actually, that's not the answer either, because how do you get those initial links, into long-term memory? You can't just figure everything out on your own. You need some lecture or explicit instruction to at least get started with what you're learning. So in fact, it looks like something more like lecture, some explicit instruction mixed in with active learning, is really probably the best way to go. And in fact, research, some of the most extensive and expensive research studies in history have shown that it's a mixture of lecture, that is explicit instruction, with active learning that actually makes it so that you can learn most effectively. So by listening to lectures, then going off and practicing, listening and practicing, you can learn most effectively. And this technique is called direct instruction. And as I mentioned, it's very, very well studied. So when it comes back to Julius Yigo, what is going on? Julius, he would sit and he would listen to the lecture. So that's explicit instruction. And then he would go out and he would practice with the javelin. So he would have lecture, active practice, lecture, active practice. And by this mixture of listening to lecture and then going out and practicing on his own, that's how he became the world champion in throwing the javelin. But what does this mean from a neuroscientific perspective? I mean, what's the difference between learning because you're getting instructed versus you actively practicing? Well, I had mentioned before that there's two sort of, or there's a set of links that get laid into long-term memory as you learn something new. But what I didn't mention was that there's two ways that those sets of links can be laid into long-term memory. The first is called the declarative system. It takes information from working memory through what's called the hippocampus and into long-term memory. The second way of learning is what's called procedural, and it goes through the basal ganglia. And as it turns out, you need both types of sets of links in order to be able to learn something well. When you learn something declaratively and learn it also procedurally, you can be both flexible and fast with what you've learned. So in fact, it's a little like this. With procedural learning, you're not conscious of it. So you may be able to solve a Rubik's Cube, but you're not really conscious of how you do it. You speak the complexity of your native language, which you've learned procedurally, and you're not conscious of how you do it. You may be learning a new language. You learn that through your declarative system. And as you're learning, you may ask a native speaker why they have these certain grammatical rules, and they'll just say, I don't know why. They're not really, they can't explain it very easily. Now, learning procedurally happens through practice, as we've already seen, whereas declarative learning happens through explicit instruction. So again, these two different systems learn in very different ways. And this procedural system, people often say, oh, it's just rote learning. You say it enough times and then you've got it. and it's just rote. Well, it turns out that is procedural learning is also rote learning is a part of procedural learning, but it's also the system you use when you're learning really, really complicated patterns. So what you're doing is you're practicing lots of different ways, you're practicing, and you begin to see the pattern that has developed, and you're using the procedural system to do that. Now, your procedural system is very fast, like learn to type, you're very fast at it, but it's also not that flexible. In other words, if somebody changed my keyboard, I would find it difficult to relearn how to type. But declarative learning is quite flexible. When you're learning things, what happens is you first, as an adult, learn something declaratively in most cases, and then when you have a part of the brain called the infralimbic cortex, and it's like monitoring what's going on out in the brain, and it'll say, oh, wait a minute, you're doing that a bunch of times. We need to not only have a declarative set of links, we need to have a procedural set of links, because you're doing it a lot, and we want to give you these sets of links so you can just do this thing without even thinking about it. And this, as Zach will tell you, is a very important part of learning to program well.
That's right, Barb. So let's talk about the procedural system as it relates to the programmer's day-to-day. So getting fluent in the procedures of your craft is unbelievably important to a software engineer. And as Barb mentioned, the idea that, shortcuts or memorization, this is just some sort of like dumb rote learning or something is not true at all. And it is incredibly important to achieve procedural fluency. So let's talk about how you might achieve procedural fluency in the areas that you may do it. So we're going to talk about hotkeys, shortcuts, and accessory tools like Bash, which is the terminal here. Now, once someone told me long ago that shortcuts were for people who wanted to be an alpha geek. And they did not mean that as a compliment. They were sort of saying that using a lot of hotkeys and shortcuts and navigating around all quickly and stuff, it's associated with this stereotype of like the uber nerd. And in my opinion, it's really, that perspective is very short-sighted. The stereotype is that the super nerd obsesses with really low-level arcane things and like little tools and whatever. And the harder or more obscure the tool or the workflow is, the cooler it is to them. Now, certainly spending all of your time messing around with tools or memorizing shortcuts is not worth it. I'm not saying this is the most important thing you can do. But early stage programmers, I believe, really discount the value of hotkeys, shortcuts, and tools like the terminal. One of the things that when I first became a software developer that really stuck out to me is that when I pair programmed with experienced engineers, the first thing that I noticed was, wow, they're so fast. Their workflow is so just like fluid and fast. They typed fast, they navigated fast. And most importantly, they solved problems fast, right? Because that's what it was all about. And they knew all these magical shortcuts that just like wrangled code in every direction and just moved things around with this extreme efficiency that I was really envious of. Now, these developers had achieved procedural fluency in their tooling. In other words, how it is that they got code on the screen and interacted with the computer, right? They knew how to move around, to find things, to get things done. And this freed their mind to focus on solving the real problems because they had that procedural system so well trained. So what can an early career developer do? Like, where are the investments that you can make to get that procedural fluency in tooling? I'm going to talk about two areas first. The first is the code editor, which is where you write your code. And the other is the terminal, which is an accessory tool that often runs your code. Okay, so if you are using a code editor like VS Code or WebStorm or one of these other famous editors, you should know how to jump to a definition, You should know how to rename a symbol across the whole code base, move a line of code down, delete a line in one keystroke, jump between lines and words quickly, and to search and find across files. Now, are these the only things that you can do, or the only things that you could possibly learn? Certainly not. But avoiding fussing with files and navigation is going to keep you in the flow of problem solving. And in my opinion, that's a baseline that's not that hard to achieve, and that helps a lot. Okay, similarly, the terminal can feel really intimidating at first, but it's hugely powerful and important. You don't need to be a terminal wizard or like a Mr. Robot super hacker person to really improve your workflow using the terminal. A small investment in some of the commands and tools that are available can take you a huge distance here. I've listed some of these commands here on the right side. If you want to screenshot it or visit the presentation later, please do. But these are sets of commands that are basic. They're not hard to understand. They're not hard to learn, but that they're really going to help you navigate that terminal in a way that's fluid. Why bother making this investment in the terminal? Well, because the terminal actually takes a lot of complex actions and behaviors, like moving around files everywhere or requesting a website or whatever, and it compresses it down into a few simple keystrokes. And if you think about a lot of what we talked about so far, it's about taking things that do a lot of that are complicated and compressing them down into something smaller, into a nice chunk, into a chunk that forms the scaffolding of your long-term learning, like Barb has mentioned in previous slides. Okay, so why might we want to condense complex behaviors into a few keystrokes? Ultimately, it's because programmers are typists. This is what we do all day. We talk to people to understand what the problem is, and then we type very specific things that make the computer do what we want it to do, right? Another powerful investment that you can make in procedural fluency is typing speed. This is a bit of a slog, right? In the sense that it does take a lot of practice to increase your typing speed. But honestly, when you meet really good programmers, almost all of them type pretty fast. It is often a sign of that fluency in the tool chain. Now, it's not absolutely necessary for you to do this. For example, there are programmers that have disabilities that, for example, use an audio interface to program and this kind of stuff. But generally speaking, when you see good typing speed, it's a shorthand for a person with a high degree of procedural fluency. When you're problem solving, you don't want typing speed to be the bottleneck. You want your thinking to be the bottleneck that you're concerned about, right? You don't want to be thinking so much faster than you're able to type. There's tons of typing tutors available. There's even some that focus on the weird keys that programmers use more often than sort of typical digital workers. This is a screenshot from the keyboard system preferences in OS X on my Mac. And one of the easiest things you can do to amp up your typing speed is to just crank both of those knobs all the way up to the sliders, I guess I should say, all the way to the right. And this will just immediately make your keyboard much faster and more responsive. Okay, so the next bit of procedural fluency for programmers is procedural fluency in language. So as I understand it, you all are studying JavaScript, which is a wonderful language to learn, especially as a first language. You'll hear a lot of nonsense online, the idea being that, the syntax doesn't really matter because all languages are accomplishing the same things. And so why would you bother memorizing syntax and all that? Well, I'm sure many of you have heard it before, right? But it's not true. Yes, for very obscure things, you'll probably have to go and look it up. But there are not many days where you'll look up, absolutely nothing. But there's a baseline of nouns and verbs and grammar in the language that you use that is required in your long-term memory to be a competent professional in that language. It's just as Barb mentioned earlier, you really couldn't say, yeah, I speak French. I just have to look up every single word and phrase in the dictionary to speak it. We would all recognize that that's kind of nonsense. And it's the same. You don't speak Java or Go or JavaScript if you have to look up every single word or grammatical construction that you use. Now, I think the best way to think about this is to imagine yourself in your native language punctuating a sentence. when you're writing, do you really want to be thinking, well, here I finished my thought, so I need to put a period, and then the next letter needs to be a capital letter. And you don't want to be thinking about this. This would slow your ability to communicate and to work to a crawl. So my recommendation here is that there's a certain set of what are often called standard library modules and basic syntax that form the nouns, verbs, and grammar of your programming language. So don't do your daily work with the principle that I can just look it up. You're not taking advantage of the procedural system if you do. And if a verb or a noun is not in long-term storage and it's not available to your procedural system, then it's also not going to be available when you're trying to solve a problem. When you see great programmers solving a problem, they can often produce multiple possible solutions based on their deep understanding of the language or framework that they're using. And they also grasp problems more quickly. Why? Because they've trained that procedural system in an understanding of the language and the tools. They're not hung up on syntax. And that is invaluable as you advance further and further in your career. So ultimately, great programmers focus on problems, not on syntax. Similar to the terminal commands I mentioned earlier, these are very basic things that I do recommend you just commit to memory. There's not too much here. Your bootcamp will cover many of these things anyway. And memorization is not, it's like not the most fun thing to think about, but there's just no way around it to being competent in your language. So this is my suggested list. These are categories of things that cover that are used in essentially all programs, and they occur in essentially all languages. So you don't want to be thinking about them in your day-to-day work. Great.
So if you're trying to memorize something, or you're trying to get something into those sets of links in long-term memory, what's the most efficient way to do that? Now, I'm going to give you 4 different possibilities that are time, tested, and people have used them for, hundreds and hundreds of years. So which one do you think of these 4 possibilities is the best way to learn? Is it to reread what you are learning? Or is it to highlight or underline? We all frequently do these things. Is it to use something like recall or retrieval practice, which is, for example, just using flashcards to check? Or is it creating a concept map where you're writing down key concepts and figuring out how they relate to one another? So of those 4 different, hopefully you've got the idea in mind that you think is the best. And it turns out that research has shown the best technique by far is retrieval practice. Why? Because when you are first learning something, for example, right now, when Zach and I are imparting this information through your declarative system into long-term memory, you're getting these very faint sets of links in your long-term memory. But each time that after you've learned it, each time you retrieve it and retrieve and retrieve, you strengthen those sets of links. And that indeed is the fastest way for you to learn. It is not the most pain-free way to learn. Pain-free is letting your eyes skim over the material again. It's so easy and it's so tempting, but you'll learn much more quickly if you use retrieval practice. So things like flashcards about things you really want to remember, and even posting Post-it notes on your mirror in the bathroom so you can review and see if you can retrieve key ideas from your brain each time you look at those notes or at the cards will help you retrieve these sets of ideas. Now, if you look at things and then you're really busy and you don't have time because you're working, we understand that, perhaps working, or you've got family obligations or something like that, what can happen is so as we show here, see these initial set of links that, for example, what you're getting right now from what we're saying. Now, let's say you're super busy, and so you don't look again or think again about what we're talking about for 3 weeks. Well, what can happen is, remember those little dendritic spines that emerge and connect when you're learning? If you are not using those spines, what can happen is your synaptic janitors can kind of clean them away because they're not being used. And you won't remember them. You physically will not remember, or you'll have to relearn what you learned before. So this is why even a simple review at night before you go to sleep of key things you've looked at or learned that day, you'll think, oh, I know them already. It's so simple. Why would I spend 2 or 3 minutes going over in my mind the key ideas I learned? Well, it's because they're super easy to remember now, but as you let them go by without using retrieval practice, they will become erased from your memory. So, in fact, we can actually see this in using light microscopy techniques. So, if you look, here's a dendrite with these little dendritic spines. This is before learning and before sleep. And this is the exact same living neuron after learning and after sleep. And you can see that there's these little dendritic spines that have grown or strengthened because of the sleep process. In fact, sleep is where your brain practices over and over again, hundreds of times, with links that are important. So this is why just before you go to sleep, if you review don't use that to be your study time, but just before you go to sleep, take a few minutes and review the key ideas. This will signal your brain, this is what I really wanted to learn. And it signals the brain about what you want it to practice with during sleep. So as it turns out, spaced repetition, that is taking an idea and working with it over multiple days, is really one of the best ways to learn. And so if you have, for example, 5 hours, don't say, I'm going to use that 5 hours on the weekend and I'm going to, or on a certain day, and I'm just going to cram for 5 hours. And that's what I've learned this week. Those 5 hours, they create weak sets of links. And in fact, your little synaptic janitor can sweep those links away. Whereas if you study 1 hour per day over 5 days, each day you're strengthening the links, but you're also strengthening the links when you're sleeping. So you're getting like twice the effect for spacing out that learning. And this, of course, is one of the best ways to learn. And it's a little bit, metaphorically speaking, like building a brick wall. You lay a layer of bricks, some mortar, bricks and mortar, but you take your time so the mortar dries and before you go too high. But if you don't do that, you'll have a structure that looks more like this. It's very poor foundation for learning. So spacing out that learning, doing it over time and repeating is really important in helping you learn effectively. Now, remember we talked about declarative and procedural learning. What's the best ways to help both systems learn? Well, retrieval practice will help both systems, and so does spaced repetition. But explanation, of course, is best for declarative, whereas procedural, varied practice and interleaving. In other words, if you have closely related ideas, interleave them. So, for example, let's say you're learning statistics or learning probability distributions, and you're trying to learn geometric, binomial, negative binomial distributions. Don't just do a dozen problems of negative binomial and another dozen of geometric or something. Once you have the basic idea, mix up those very closely related distributions or algorithms or whatever you're learning, so you know what the differences are and when to pull a specific technique out and begin working with it. So you can think of it like this. You've got these different types of distributions. Say you've got negative, binomial, geometric, and what have you. If you mix them up in your practice, then you will begin to become aware of when you need to use what and why.
So if you're trying to pursue this course of spaced repetition, memorizing syntax so that you get procedural fluency, understanding shortcuts and hotkeys and all that kind of stuff, as Barb mentioned, flashcards are powerful. This is a great, it's a simple and effective program called Anki, A-N-K-I. One cool thing about Anki is that it already will plan the intervals for your spaced repetition for you. So you can, to some extent, you can lean on Anki to know, it'll tell you, okay, it's time to review this idea. Okay, it's time to review this idea. And all you have to do is maintain your set of programming flashcards. There's no reason to leave your memorization up to chance. You can memorize almost anything through spaced repetition, as Barb has pointed out. Essentially, all programming languages and frameworks have flashcard decks available online, and you can load these decks into a program like Anki, which is free. This is actually a card from my own deck from when I was learning JavaScript, and I would go on to I would go into my laptop on the New York subway where I was living at the time, or on my phone, and do my review each morning as I went where I needed to go. You can, if you go onto GitHub, github.com, which is a famous code repository, and you search for language or framework flashcards, usually you can find a deck there. So that's where I would encourage you to look for one if you're interested. Great. So let's talk about programming as a craft, as a discipline. We've talked about a lot of details here about tools and syntax and all this, but let's talk about programming as the craft itself. Programming is a procedural craft. What that means is that as you go higher and higher in programming expertise, you start finding yourself encountering more and more abstract things. For instance, you may end up thinking more than actually writing code, right? You may end up designing a system rather than implementing all the details of the system. Or you might be the person that takes existing code and refactors it. In other words, sort of repatterns it in a nicer way. And that can be very, very abstract conceptual work. Now, you can't reach these high levels of abstraction if you don't have procedural fluency over the concrete stuff, the kinds of pieces and tools that we've been talking about so far. As we saw in Barb's remarks, procedural fluency, it offloads the cognitive load onto your muscle memory, onto your procedural system. Procedural mastery leaves more resources for thinking because of what you're not thinking about. You're not thinking about, what's that hotkey again? How do I write an array again? How do I declare a variable that's constant in this way, right? Long-term success in programming really depends on your procedural system holding all those complex patterns and all that understanding of these lower level complexities that we've been talking about, and the technology that powers your product. Everything we've discussed so far, the hotkeys, the memorization, the use of the focus and diffuse modes, all of it is there to drive deep understanding into your brain. Now, as you graduate from your boot camp and you enter the industry, you will also discover that procedural fluency is rewarded by employers and rewarded by the industry. People want programmers who can solve problems and ship code. They don't just want talkers who have a conceptual understanding of the problem or conceptually understand technology. They need people who can build and who understand the details so that they can have a conceptual understanding of the technology. But you can't reach that high abstraction level without that concrete stuff first. Okay, ultimately, great programmers use both the declarative and the procedural systems. So I think of this as programmer intuition. Great programmers have the ability to understand systems conceptually, but their thinking is informed and disciplined by that procedural understanding, by the fluency they have in their tools and their craft. Now, Barb has talked a bit about how the procedural system, it's almost like training your unconscious mind. There's like a subconscious function that gets trained over time. This is the basis for what we might think of as programmer intuition. Programmer intuition is like the holy grail of programming skill. And I would suspect that some of you have encountered this already, even at an early phase in your programming career. Amazing programmers can often look at an error or even just hear someone vaguely describe a problem. And then often without even seeing the details, they will know what's going on. They'll know where to look or what is causing the problem. And for a given system, like a system that you're building at your future job, you grow that intuition over time about where problems come from and, without even necessarily having to look at it. And this is why, a senior plus engineer can solve a problem in 20 minutes that might take a more junior engineer 5 hours. It's because of that deep basis of understanding and the way that procedural system has been trained. Now, notice that this is not conceptual. This is not just like the engineer being able to articulate to you in every way why it is that they came to that conclusion. They may not even be able to explain it to you. But the intuition has guided them through this extremely complex space to know where to look and how to intuit what's going on in a system. Programmer intuition is the way that procedural system trains your subconscious mind. With enough practice and enough exposure, you get to recognize these patterns, and that helps you train that intuition. And that it also helps you have an intuition for the kinds of things that allow you to achieve higher levels of software expertise, like technical risk when you're designing a system or design issues in a system. You evaluate those things often based on your intuition. Now, I think this is the mark of true expertise. It takes a long time to achieve, but it's absolutely possible for you or anyone else who wants to do the work to achieve it. And it fuses that heady abstract world of the declarative system where you can talk fluently about technology with that murky subconscious realm of the procedural system. These things come together to create true expertise. And the kinds of skills that we've talked about with you today, they can help you train both of those systems and help you reach that level of expertise. Now let's revisit Julius Jaego briefly. Julius is a person who did not start with everything in his favor. This is the next slide, Barb, thank you. But he found a way to structure his learning and to achieve world-class expertise despite not having everything in his favor. Programming takes practice, just like javelin throwing or just like learning the violin or learning French or anything else. But it is very much possible for you, wherever you are in your life or in your career, to reach expert levels of programming expertise. And these specific concrete skills that you can use to retrain your brain and achieve this are, let's recap, managing your working memory, using that focused and diffuse mode intelligently, avoiding digital distraction and being intentional about how you deal with your procrastination, spaced repetition and recall using a tool like flashcards so that you memorize these table stakes things that you need in your discipline, like the syntax of a language or tools, and then investing in procedural fluency. In other words, getting really good at your first language, getting really good at your tool chain. These things can take you from beginner to expert as an engineer. And best of luck to you on your coding journey. Thanks very much.
Okay. Let's see. Well, thank you, Jess, and it's back over to you.
Yeah. If you don't mind, can we take up just a little bit more of your time with a little bit of question and answer? This has been absolutely fascinating. And I would love if we could get, and if our amazing, I'm so sorry that Ramon has had to run off, so you all are stuck with me for a bit. We had some really, really great questions. And if any of our learners have questions for you, I'd be so happy to put them forward.
Oh, well, I think Zach and I are both very happy to do that. I do have 6 minutes.
We'll go super fast. We
But
had someone who asked, "Oh, if it's really good for me to learn or review right before I go to bed, can I listen to podcasts before I go to sleep to sort of sneak in a little bit of review?"
sure. Actually, it's been found that you learn just as well by listening to a book or a podcast or whatever as you do by reading. So the key idea is don't just listen to it though, because that's a little bit like rereading. I mean, you can get the initial information. When you're done with the podcast, ask yourself, what were those key ideas in the podcast? And that's going to really help you learn. But oh, there's fantastic information in podcasts. So absolutely, yes.
So you can't just listen. You'll probably want to like sort of mentally pick it up and look at it with your brain to get sort of the full recall effect.
I think so. See, the problem I have is when I'm listening to podcasts, I'm often on my walking machine. So it's like I can't like take a note of the key things I want to remember. So sometimes I'll like stop it and I'll try to be like, okay, now don't forget it's the habanula that does this, and I'll try
Oh
to.
yeah, the habanula, obviously.
And that's the hot thing right now. But whatever it is, I'm trying to remember. I'll try to stop and then like if it's 4 or 5 stops, I'll do a finger trick where you're like one. The first stop is you've got it at here and then here and here and here, and sometimes that physical location of your fingers. This was something that I used when I was working as a translator or an interpreter. I would often, first idea, because somebody will babble for like 6 minutes and you've got to remember all this stuff. So I'd be like sitting there going, oh, there's this idea, this idea, this idea, and this idea. And then I just remember, oh, I've got 4 ideas, and I try to, and Zach probably has similar experiences from his learning Spanish.
Oh, we could have a whole session about language learning. If it's not rude, Barb, I'm going to hit you with one or two more quick questions that are very you flavored. And if Zach, if I can steal you for an extra minute or two, we've got a bunch of programmer ones.
That's fine.
Look, you all were like, yeah, I'll make the time to come on. And I'm like, good, I'll just take every bit of that time. We've had a couple different people come on with different variations of this question to say, hey, I've got ADHD, or for ADHD, do you have any sort of additional advice for folks from this space? I know there's a bunch out there, but hey, it's especially challenging for me to focus. How might I better get between focused and diffuse? Or really, I think for ADHD, how would I better get into that focused mode if this is challenging?
Okay, so ADHD is a very interesting in that you think you can't concentrate very well, but actually individuals with ADHD can concentrate super well on what interests them. The challenge is that the default mode can pop up into place much more easily, especially when something is not of interest to you. But if it is of interest, you can ignore that default mode. That's why many people with ADHD they're great at video games because they're in part designed, to capture your attention, but also they're fascinating. And so it's easy to focus. So the Pomodoro technique is exceptionally helpful for those with ADHD. And the first thing is simply it teaches you to get stuff out of the way. So there's no interruptions that can help, that default mode network to pop up into place. Also, if you wear headphones, I have like this, I wish I had them with me. I have like 3 pairs in my bedroom, but these massive 31 dB, they take out everything. It's not just noise canceling. Those also signal my brain to keep working on things. So if you do have ADHD, just remember that number one, it's affiliated with creativity. Number two, you can concentrate, but the trick is to find ways to get yourself really motivated about what you want to learn or do. And oftentimes, if you even just sit there and go, I am super fascinated by this thing, and make yourself believe it, you can do it. You will be surprised that will help release dopamine, tonic dopamine, and help with your motivation, and you can still really learn quite successfully.
Fabulous. So we've got so many good questions. Oh no. And here's a really good one. This kind of comes right in. Well, can learning with music be beneficial, or is this a distraction? I feel like the headphones were kind of a cheat for what the answer for this is going to be.
Oh, no, but I should say, and this is actually closely related to the last question, and that is that it depends on what your working memory capacity is and also what you're doing. So, if you have a very high capacity working memory, it's often easy for you to listen to music and be learning. It's just the way of things. So, also, if you have ADHD, there's if you music does seem to help sometimes because it helps entrain certain systems of the brain, and it can help you to focus more effectively. So for many people, for myself for example, I don't have a big enough working memory capacity, and I find music to be distracting. I can either do one or the other. So it really just depends on you. Watch, are you effective with your learning? If so, it's probably fine to listen to music. And with that, I probably better go to my
No, of
next meeting.
course.
Again,
And we're going to continue to kindly bully Zach, if that's quite all right, with a ton of questions.
I think
Oh,
that.
wait. I've got one drive-by, like literal, real fast. I think it's a yes, no. Do the number of memory arms on your octopus change with age?
Oh, good question. No, they're pretty fixed, but so you can't really increase the number of. I mean, I suppose if you're in an accident, yes, it will change your working memory. It can change your working memory capacity if you get a concussion or something of that nature. But what does change is your ability to hold things in working memory. So you've got 4 arms, you can hold them, but they might slip out more easily if you're older. The best way they found to actually help improve working memory capacity in the sense of being able to pay attention and focus is to use action style video games. And that has been shown to be like, if you're 65 and you want to get more of that focusing skill that you had as a young person, action style, the kind of video games where somebody could leap out and kill you, those really help develop your attentional skills and bring them back in older people.
All right, jump scare video games. I'm so sorry. I was like, hey, this is so interesting. I'm going to let you go. Barbara, thank you so much for your time.
Oh, it's my pleasure. Zach, I'll pop you an email as soon as I'm done with the other meeting.
I'm just so unkind about stealing Zach for an extra couple minutes. You're so patient. So we've got a bunch of programming questions. And if it's not mean, I might gently disagree with you once or twice, even though you're the expert.
That's fine.
Just because what is a session without any conflict? So we had someone asking a fantastic question and I got distracted. Oh, so I've seen a couple variations on this. Do you have any ideas on how we might work with or confront or even make our peace with imposter syndrome in programming?
Yeah, I mean, it's certainly a real thing, but the kind of bad news is that I think it sort of never goes away because the world of technology is so big, and in a way, it's so demanding, and it can be so difficult that you always, in some way, can feel like an imposter. For instance, the company where I work in, it's like, okay, I know a lot about the system, but it's so big that I will inevitably encounter some piece of it that I hadn't looked at before. And in that moment, you feel like, oh, am I competent? Do I know what I'm doing? And the imposter syndrome starts showing up. My opinion is that it is an inevitable thing. It's a problem. You have to try not to let it consume you. And the number one thing that helps with imposter syndrome is having success. In other words, writing a program that works, getting your first job, these kinds of things. And the number one way to do that is to just be serious about how you're learning your craft. It's so many things are solved, in my opinion, for the professional programmer by shipping code. You're like, oh, I don't know what to do. Oh, I don't know how to learn. Oh, I feel like an imposter. Oh, I don't know how to get my first job. It's just shipping code solves so many problems that that's my go-to technique for dealing with that.
If I can add one more in there, because I agree so strongly where you're like, hey, these successes we get along the way. One thing I do is when I've had a specific type of success, I will find or purchase a small weird thing. I've got a antique Japanese railway multimeter. Nobody, but I got that when I got a fancy job. And now every time I'm like, oh, I have no idea what I'm doing. Oh, that weird thing exists for a reason. Oh, I remember when I did something decent.
I like that a lot. I actually keep I keep a log of nice messages and emails and other things that people send me. I know it sounds ridiculous, but it's like if you're feeling bad about yourself, you just go and look at those things. You realize, oh, I'm not so bad after all. Like, oh, I did this thing, or this customer was happy, or like this person I worked with said there was a pleasure working together, or whatever. And it just kind of like it short circuits that kind of downward spiral that the imposter syndrome can create.
I love that. That's charming. I've got a question that you may or may not have the answer to, but if you've got the answer, I'm going to be thrilled. You talked about this flow state. How can we get there real fast? How can I get there right now, please?
Yeah, so I mean, obviously, there's no like magic flow pill or flow button, but 100% getting rid of the distraction element like is a prerequisite to getting into that flow state. So clearing away all of those distractions and letting yourself be alone with like yourself in the problem. And I also find that the thing that stands between myself and flow is usually a sense of dread about starting the thing. It's not so much like once you've started it, you feel like, oh, I'm going downhill. I can keep doing this. This isn't so bad. Like, here we go, right? So again, using that Pomodoro technique to get through that first phase. I often, like if I'm stuck on something, I can use the Pomodoro and then I don't stop. I just keep going. If I'm in flow, I'm like, I don't have to stop at 25 minutes. You can, right? If you're stuck, but just keep working, right? If you're in the flow state, because it is hard to achieve, right? And when you're in it, it's great. But the number one thing is to get rid of all the adjacent stuff that's going to pull you out of the flow state. Nothing is more frustrating than getting like a trivial text message that pulls you out of flow and then you can't get back in or something, right?
So I've got a question that comes right into your advice around this, because you said, oh, it's really about getting into this flow state. It's about, and really you mentioned getting started. So we've got a learner who says, you know what, I've done a ton of courses. And sometimes when we're talking about learning in tech, we describe this as tutorial hell, don't we? So say, oh, I've done a bunch of courses and then I finish those and I don't really know where to go next. Do you have any sort of advice about moving past these sandbox environments, or moving out of these tutorials and making a thing or breaking a thing?
Yeah, yeah, absolutely. I mean, that's 100% a real thing. Like tutorial hell. Like I went through tutorial hell when I was learning as well. And there is, in my opinion, there's like a sort of missing middle in programmer education that usually just occurs on the job. So you have these tutorial things which are meant to train you in syntax. They're meant to like make a toy program, for example. And then as you get advanced, you end up in these like, 3-day seminars about design patterns and, cloud infrastructure and stuff. And that's like super advanced, right? And it's like, well, I don't know. How do I get from like the toy thing to like architecting a cloud solution? Like what's in here? In my opinion, what's in there is basically building something where you personally are responsible for imposing order on the problem. Okay. So what I mean by that is, let's say, for example, you're really into, you're really into like Twitter or something. Making a Twitter scraper that then, uses a library to get sentiment out of the tweets, or like some kind of thing that you're into, that's going to take you through that middle, because there are not going to be any instructions for how to accomplish that task. That is really the big difference. Is if you are given the order of a tutorial, you are able to build within the confines of someone else's order. But when you get on the job, someone says, hey, this button's supposed to do this other thing, and it needs to do this and pop a window. And you're like, oh, I have to actually figure out how to get from A to B. So for me, I took this to an extreme length. I did this thing that I called Python-a-thon, which was I rented an Airbnb that was really cheap near where I lived at that time for a month. And I went there, and my goal was to ship as many applications using Python as I possibly could. And I went there with a list of things that I thought would be fun. So I'm not trying to pick like the most challenging possible thing or whatever. It's things that would hold my interest, because I, like everyone else, I'm going to get discouraged and want to give up and, and everything. Right. So I ended up shipping, I think it was like maybe like 7 small applications. And each of those applications was like, hey, I'm gonna, it's gonna make me spin up a web server. It's gonna make me build a front end, and it's gonna make me connect those 2 things and like have this interaction. So it was like a full stack experience, because that full stack experience is the thing that's gonna make you get out of, I know how to do a toy program, but I don't know how to like build a feature from end to end. So pick something fun and build it and actually ship it and actually put it on your GitHub and actually then write a short blog post that describes the thing. And you will be already like 75% of the way to getting your first job. If you can just do that stuff.
I'm going to ask you one more question, because we've been taking up all of your time and you've been so patient. And I love this because a lot of the questions have been, hey, Zach, you mentioned this thing. How do I get to do this thing? And we've got another one of those questions to say, Zach, you mentioned procedural fluency. How do I get that? Which sounds like just practice. But way more importantly, how do I know when I've got it?
Yeah, it's a great question. I mean, there's no like perfectly objective standard to understand I have achieved the state of procedural fluency, right? Because you can be fluent, maybe you could be fluent as a typist, but maybe less fluent in the terminal, or maybe quite fluent in your IDE, but maybe not as fluent in a new language you're learning. So you kind of want to measure it based on the thing that you're looking at, right? But there are definitely some ways to measure it. So I'll show you, for example, this is, something's fell off. This is my keyboard. You'll notice that I have the actual keys covered up with Post-it notes. The reason is why? Because that is a really objective way of understanding how much fluency do I have in my keyboard. As in, I literally cannot see the keys. So if I can't see the keys and I still type competently, that means I have successfully trained that level of fluency, right? For something like a language, you could think about, you can look at, well, how often am I consulting the docs? When I go and I write something, am I able to pull this out of memory, or am I not? In the terminal, a good example would be, can you write a bash script for a simple task without looking up the syntax? Because if you can, it means that, hey, like you are really fluent in that tool. So it's just looking for simple ways in your day-to-day to just like raise your bar just a little bit, to be like, what if I couldn't see my keyboard? What if I had to write this bash script without looking at the docs? Like, how much do I really know? And oftentimes you're not as fluent as you think, and that's okay, because it's just an ongoing process, and that compounds over time, and it just takes time.
I love how you're like, yeah, cover your keyboard. And deep in my heart, I'm like, yeah, absolutely not. Lovingly and affectionately and respectfully, I'm like, yeah, y'all have fun with that. Zach,
it's not necessary, certainly.
it's reasonably hardcore. So you're like, yeah, additional challenges. And I'm like, nah, additional challenges. You've been an absolute gift. Thank you so much for coming to talk to us today. If folks want to check out where you live on the web, it's zach.dev, I believe.
That's right. Feel free to visit my website. I'm also my name, Zach Caceres, on Twitter. I'm always happy to talk to people that are, doing this transition, because it's a difficult transition. And so please feel to reach out to me if you really want to, and I'll do my best to respond. So thank you all so much. And you really can do this. You really can make it through the journey. It's a challenge, but you can totally do it. And I really wish you all the best on that.
Zach, thank you again. I'm going to send you away. And I'm going to send myself away as well. You all have been absolutely fantastic. Thank you so much for joining us. If you want to come back and review in a spaced interval this video later, it'll be up on Twitch for a while, and it'll be up on the Class Central YouTube. For those of you who are part of the bootcamp, if you want, no pressure. We've got some open office hours this Saturday, but otherwise, your regular lessons for both the JavaScript bootcamp and for the web development bootcamp will start right back at their regular times on Monday. Thank you so much, and please have the easiest possible day. Bye, team.